Good morning, students. Today we will be solving some numerical questions from the formula that we discussed in the lesson motion. We have discussed several terms that are used for describing motion: distance, displacement, speed, velocity, acceleration. Thereafter we discussed graphs. We obtained the equations of motion. So using these we will be solving some numericals. So let's begin with the first. A particle moves through 3 meter due east and then 4 meter due north. How much is the distance traveled? The net displacement. Now, as in this question you have to take care of the directions for displacement. So first of all, let's find out how to figure out the 4 cardinal directions, that is north, south, east and west. So for this we will follow the same convention as we usually do in the map. So in this manner, let's first of all mark the directions north, south, east and west. This will help us in marking the distances properly, distances traveled in the given directions properly. So now that we have marked the 4 cardinal directions, so following this convention we will be drawing a rough sketch using the values given in the question. So first of all, the particle moves through 3 meter due east. So let this distance be given by OA, and this is towards east. So it is 3 meter. Next, the particle moves 4 meter due north. So let this be 4 meter. Okay. So this is 4 meter towards north. Let this position be marked as B. 4 kilometers, sorry, it's 4 meter. So this is the path followed by the particle. So now we have to find the distance traveled and the displacement. So first of all, distance traveled. Now this will be equal to the total path length. So that is 3 meter plus 4 meter. It is equal to 7 meter. Now we know that distance doesn't depend upon direction. So we don't need to remember in which direction it was traveling for finding out the distance. So simply adding up the path length, that will give us the distance. Now referring to the picture again for finding the displacement. It began its journey from O and it ended at B. Now displacement is found by drawing a straight line between the initial and the final positions. Let's slightly move it a little bit. Yes. So it is OB. So OB is the displacement, net displacement of the particle. Now as you can see that OAB is a right angle triangle. So OB square will be equal to OS square plus AB square. Can you tell me which formula I have used? Obviously it is Pythagoras Theorem. Now let's substitute the values. So OA is 3 meter and AB is 4 meter. So 3 meter whole square plus 4 meter whole square. Therefore OB is equal to root over 9 meter square plus 16 meter square. So that will be equal to root over 25 meter square. So taking the square root you get 5 meter. So the net displacement is 5 meter, and as we had already calculated, distance traveled is 7 meter. So this is the solution of the first question. Question number 2. A car covers 30 km in 30 minutes and the next 30 km in 40 minutes. Calculate the average speed for the entire journey. Let's find out total distance. Total distance is 30 km plus 30 km. So that will give you total distance equal to 60 km. Now for finding out total time, first of all check the unit. You can see the time is given in minutes. So for finding out speed, we need to remember to convert the value of time. But first find out the total time. Total time 30 minute plus 40 minute. So this will be 70 minutes. So total time is 70 minutes. Average speed. Remember, whenever we are solving any question, we have to write down the formula. So average speed is equal to total distance divided by total time. Let's substitute the values. Total distance 60 km divided by total time 70 minute, but we have to convert it into hour. So dividing it by 60 will convert from minute to hour. So now we have to solve. This will become 3600. The 60 will go to the numerator part. So 3600 divided by 70 km per hour. We can simply cancel out 1 0. Rest we have to divide. So 360 by 7 will be equal to 51.4 km per hour. So this is the average speed for the entire journey. Question number 3. An insect moves around a circular path of radius 10 cm with a constant speed. If it takes 1 minute to move from a point to a diametrically opposite point, find distance covered, speed, displacement, average velocity. So using the given values, we have to find 4 different values: distance, speed, displacement, average velocity. Now we need to visualize the path followed by the insect during its entire course of journey. For that, let us draw the path followed by the insect. It follows a circular path, so let's draw a circle. It is of radius 10 centimeter. Let us just adjust the path a little bit. Yes, so this is the circle. The circular path given radius is 10 centimeter. Now it is moving from one point to a diametrically opposite point. So for that, let us show the diameter of the circle. Now the diameter is a straight line passing through the center. So this is the diameter, which distributes the circle into 2 equal halves. So let us mark it as AB and the center as O. So radius is 10 centimeter, obviously. OB and OA both are equal to 10 centimeter. Let us mark the direction. It is traveling, suppose, from A to B in 1 minute. So first we need to find out the distance covered. Now just see the path. It is traveling from A to B. So let us mark one more point as C. So it is traveling from A to B via C. So ACB. Obviously it is a semicircular path. So we know that the circumference of a circle is given by 2 pi r. So for semicircle it should be pi r. So substituting the value of pi, what is the value of pi? Is equal to 3.14 and radius is given 10 centimeter. So multiplying we get 31.4 centimeter. So this is the distance covered in 1 minute by the insect. Next, we have to find the speed. So again, first we have to write down the formula. Speed is distance divided by time. So just now we have found distance as 31.4 centimeter and given time is 1 minute. So simply speed comes out 31.4 centimeter per minute. Third, we have to find out displacement. Now see the picture again. It is traveling from A to B. So joining the initial and the final point, you get AB, which is the diameter. So the length of the diameter will give displacement. Displacement is equal to AB. So it is twice the radius, and radius was 10 centimeters. So 2 into 10 centimeter will give you 20 centimeters. So that is the displacement. Now we are left with the fourth part of this question. We have to find out average velocity. Now average velocity is given by the displacement divided by time. So what is the displacement? 20 centimeter. And what is the time? 1 minute. So 20 centimeter divided by 1 minute. So that will give you 20 centimeter per minute. So that is the average velocity, and it is in the direction from A to B. So this is the solution for this question. Let's quickly move to the next question. A train is moving at a speed of 40 km per hour at 10 am and at 50 km at 10:02 am. Assuming that the train moves along a straight track and the acceleration is constant, find the value of acceleration. So first we have to identify the given values. So given initial velocity 40 km per hour, final velocity 50 km per hour. What is the time? Time interval is 10 am to 10 or 2 am. So time is 2 minutes. Again convert it from minute to hour. So 2 by 60. So using these three values we have to find acceleration. Acceleration is v minus u by t. So 50 km per hour, v minus u is 40 km per hour divided by time. Time is 2 by 60 hour. So let's do the calculation. 50 minus 40 will give you how much? 10 km per hour divided by 2. Now that 60 will go to the numerator. So in the denominator hour is left. Let's do the calculation. So by 2 you can cancel out 60 as 30. 30. Okay. So now you can multiply. So 30 into 10, that gives you 300, and then kilometer per hour square. Right? That is the acceleration of the train. Next question. A particle with a velocity of 2 meter per second at t equal to 0, that is the starting, moves along a straight line with a constant acceleration of 0.2 meter per second square. Find the displacement of the particle in 10 seconds. Beginning again with the given values. What is the initial velocity? 2 meter per second. At time equal to 0. What is the total time? 10 seconds. It is given in the question. What is the acceleration? A is 0.2 meter per second square. Now we have these three values, and using this we have to find out what? Displacement. So can you identify which equation? S equal to ut plus half a t square. It is the second equation of motion. So using this formula, let's substitute the values. Okay, so u is 2 meter per second multiplied by time is 10 second, plus half into a is 0.2. let's write it as 2 by 10 meter per second square, and then t square. So time is 10 seconds, so 10 second is square. So this calculation has to be done. Find out the displacement of the particle, isn't it? So let's proceed with the calculation part. Now let's see what we can cancel out. We can cancel out second and second in the first part. In the second part you can cancel out 2. Second square gets cancelled. So let's do the multiplication. So you are left with 20 meter. See, 2 meter into 10. And in the second part there is 10 in the denominator and there is 10 square. So you can cancel out 1 10. And you are left with another 10. So that is 10 meter plus 10 meter. So 20 meter plus 10 meter, that is 30 meter. So this is the displacement of the particle. Next question. A particle is pushed along a horizontal surface in such a way that it starts with a velocity of 12 meter per second. Its velocity decreases at a rate of 0.5 meter per second square. Find the time taken to come to rest and distance traveled during this time. Now see, the particle starts with a velocity of 12 meter per second. So initial velocity is 12 meter per second. Then see the rate at which velocity decreases. So this is acceleration, 0.5 meter per second square. But see, the word is decreases. So we have to put a negative sign. Now, apart from that, the object is finally coming to rest. So final velocity is 0. So what we need to find out using these values? We have to find the time taken and the distance traveled. So using these three values, you have to find out the time taken first of all. So let's use this formula. That is the first equation of motion. V equal to u plus at. So substituting the values, V is 0 equal to u is 12 meter per second, A is minus 0.5 meter per second square multiplied by t. Let's put the value inside brackets. So now you get, see, on multiplying that negative term, the term with negative sign, if you bring it to the other side, it becomes positive. So you get 0.5 meter per second square into t equal to 12 meter per second. Cancelling the units, you are left with 12 by 0.5, isn't it? So that gives you 24 seconds. So this is the time taken. So once we are done with finding out the total time, now we have to find out the distance traveled. Second part of the question. So for finding distance, let's use the third equation of motion. V square equal to u square plus 2as. V is 0, u 12 meter per second. So square of that plus 2 into A is minus 0.5 meter per second square multiplied by S. S has to be found. Don't get confused with the symbol for second and the symbol for distance. So on calculating the values, we get this much. See, 2 into 0.5, that gives you 1 minus 1 actually. So bring it to the other side of the equation, that becomes positive. So 1 meter per second square multiplied by S, and then 12 square is 144. Now very quickly you can calculate the value for S after cancelling the units. So S is how much? 144 meter. So this is the answer for the second part of the question. Next question. A car moving along a straight line at a speed of 54 km per hour stops in 5 seconds after the brakes are applied. Plot the graph of speed versus time. Using the graph, find the distance covered by the car after the brakes are applied. Again, identify 54 km per hour stops in 5 seconds. So 54 km per hour is initial velocity, stops, this means final velocity, that is 0, and time, how much time? 5 seconds. So always begin solving a numerical by the correct identification of the given values. Unless you are able to do this, you are not able to find a proper solution to the question asked. So identification is extremely important. Time is given in seconds, so let's very quickly convert the value of initial velocity into meter per second by multiplying with 5 by 18. So initial velocity is 15 meter per second, final is 0, and time is 5 seconds. These three values, okay, has to be used while plotting the graph. At time 0, speed is 15 meter per second, at time 5 seconds, speed is 0. So let's plot the speed versus time graph. Now for plotting a graph, we need to have the axis. Now I will suggest that you will draw the graph on a piece of graph paper, but I am drawing the graph on the board to give you an idea of how the graph is going to look like. But whenever any value is given for plotting the graph, it is always appropriate to use a graph paper. Now I am marking the values of speed along the y-axis and time along the x-axis. Why am I doing it? That I have already explained in my previous class on graph. Speed is the dependent quantity, time is the independent quantity. So for time I have maintained a gap of 1, and for speed a gap of 5 has been maintained. So at time 0, what was the speed? 15, and at time 5, what was the speed? 0. So we have to join these 2 points, isn't it? So let us join these 2 points with a line. So that will give us the graph. Okay. So this is the speed versus time graph. This is how the graph is going to look like. Now this graph has to be used to find the distance. So do you remember how to find out distance using graph? Let's mark the points as A and B. Now you get a triangle OAB. So this shaded area of the shaded area is going to give you the distance. Estimate of distance is found by finding out the area under the speed versus time graph. So for this we will find area of triangle OAB. Now it is a right angle triangle, so area is half into base into height. What is the base? OB. Half into OB, and what is the height? OA. Half into OB into A. Let's substitute the values. OB is and OA. So height is 15 meter per second and base is 5 seconds. OA is 15 meter per second, OB is 5 second. So cancelling out second, you are left with 15 by 2 into 5. So that is 37.5 meter. 15 into 5 is 75, 75 by 2. 37.5 meter is the distance. Now comes the important part. This is going to be your home assignment. Okay? Using the given graph, find the distance traveled in the time interval 0 to 40 seconds. A graph has already been drawn for you. You have to use the values in this graph to find out the distance traveled. So we will solve this.